Hey, Algebra 1 Part 2. Today, what we're going to do is, I say quick little lesson, and then you're going to practice on Khan Academy so I can monitor you while I'm out. So today's essential question is, how can we solve a system of equations by graphing, taking out all the words from the word problems? Can we just graph and find a solution? So first off, let's go over these definitions. By the way, you're going to need to pause a couple times throughout this because I'm just going to run through it, and well, I'm not watching to see if anybody writes anything down, so you have to be in control of the pause. All right, couple definitions. First off, a system of equations is two or more equations at one time. This is why we had two equations during our word problem days. Kind of looks like sometimes it could be just two linear equations. Sometimes it could be like a circle with linear equation. Sometimes it could be really weird. But either way, a system is when you have two equations going on at one time. A solution to a system is any ordered pair that makes both equations true. Could be one ordered pair, could be two ordered pairs, could be three, depending on maybe what the shape is looking like. But either way, some of our options will be like maybe just an ordered pair. We could say infinitely many solutions if we get that. No solution if nothing works. All right, so let's look at the following system by graphing. I'm going to use two different colors. So if you're a type of person who really wants to do colors, pause the video and go get some colored pencils from the kitchen table. Let's recall how to graph something in slope-intercept form. If you have an equation in slope-intercept form, I am going to start on the y-axis at 0, -3, and then I'm going to move in the direction of slope. Slope right now is up 2, right 1. So up 2, right 1. So after I get some points, I'm going to graph. Just a little note, because we took out the words, it is okay to have arrows on our lines. Let's look at the second problem. I'm going to pick up my other color and do slope-intercept form with that, where I'm going to start at 0, -1, and then I'm going to move in the direction of, well, this is a 1 in front of the x, so I'm going to move up 1, right 1. What's nice about whenever you take out the words, typically you should be crossing somewhere nice, and there shouldn't be any question about it. It looks like the solution to this would be 2, 1. So I'm going to write down the point 2, 1, and let's just make sure that it checks out. If you take 2 times the x-coordinate 2, you get a total of 4. Take away 3, you are at the y-coordinate, which is 1. Let's check the next one. If you plug in the x-coordinate 2, and you take away 1, you get the y-coordinate 1. So it checks out. 2, 1 is the solution. Moving on to the next one. I'm going to use slope-intercept form, again, probably for both of these, in two different colors. So for y equals 3x minus 2, I'm going to start at 0, 2, 0, -2, and then I'm going to move up 3, right 1. I connect my points, make sure I put arrows, because now that we're not dealing with words, whoops, that looks terrible. Okay. Next. So I want to stress, if you've never watched one of my videos, I just start jumping into the next thing. So you have to get used to that pause button. And then maybe you have to like rewind and listen. I don't know. All right. So because there is nothing in the y-intercept spot, the y-intercept's going to be 0. So I start at 0, 0, and then I'm going to move up 3, right 1. So after I graph it, I start analyzing, like, wait, both of these are going to move up 3, right 1, and they're never going to cross. In this situation, we created parallel lines, and when you have parallel lines, there's not going to be any solution. So this is an example of a no solution when you have parallel lines. So in this next one, these both are in standard form. So let's review standard form, how to find x and y intercepts. To find your x-intercept, you put a 0 in for y, and we realize our x-intercept is going to be 1, 0. To find your y-intercept, you put a 0 in for the x-coordinate, and we realize the y-intercept is going to be 0, 1. I'll graph that and connect the 2 points. So similarly, number 2, I'm going to find its x and y intercepts. So I'm kind of zipping through and forgot to press play. Anyway, you put a 0 in for y, but it wipes out that term, so I'm just left with 2x equal to 2. If you divide both sides by 2, you realize that the x-coordinate is 1, or the x-intercept is 1. So going over to the y-intercept, when you plug a 0 in for the x-coordinate, you're just left with 2y equals 2, and the y-intercept is going to be 0, 1. Let's plot those points. And you might be having a red flag because, wait a second, 1, 0, and 0, 1 we already plotted. And if we graph that line, oops, there we go. And if we graph that line, we basically are on top of the other line. When you are basically graphing the same exact line, they share every single one of these points, not just the x and y intercepts, but every single one. Like, what is this? Maybe negative 4.5, 5.5? So this is an example of infinitely many solutions. So in a moment, the program is going to pause so you can do practice A. I want you to put in your answer, and then I'll show you what the answer is. So what I first want you to do is take some time, do practice D. You're going to put in your answer, and then I'll show you the answer. So answer is the following. What I need you to do is pause and clean up your work, because now you're about to experience practice E. So I'm going to ask you what your answer to practice E is, and then we'll move on to F. So with this problem, go ahead and press pause so you can sort of see how we got the same line. Now we're going to go on to problem F. So our final answer, go ahead and press pause. What I want you to do is get on Khan Academy. See if you can do this now on your own. The expectation on Khan Academy, 75% accuracy. Let's do this now so we don't have to worry about it later. See you tomorrow.